Okay, so this week's set of questions, our third week of review questions, these are the topics. I've linked the Hegarty Maths clip, so if you want to revise any of them, if you find that you're not getting the answers or you're not confident on the answers across the week, do check out the clips on Hegarty Maths. Do feel free to ask me questions if you're not sure about anything, or send me your answers if you want to check whether they're correct. Hopefully going through the first days here will give you some confidence if you've managed to do those questions. If not, hopefully it'll give you some idea about how you might want to sort of tackle them. We're going to start off with multiplying decimals. So we've got 0.24 times 6.5. So we're looking at, basically, I don't like multiplying decimals. Some of you I know will try and write out the column multiplication method with decimals. You end up guessing where the decimal point goes. So I don't want us to be doing that. What I want us to be doing is thinking of, well, what would this be without decimals? And if I got rid of the decimals, I'd just have 24 times 65. So let's work that out first. 24 times 65, and I'm going to use the grid method to work it out. So 24, I'm going to split into 20 and 4. 65, I'm going to split into 60 and 5, and I'm just going to fill these boxes up. So I've got 60 times 20, 6 times 2 is 12, so 60 times 20 is 1,200. Because I'm multiplying, if you think 60 times 2 would be 120, so 60 times 20 is 10 times bigger, 1,200. Okay, 4 times 6 would be 24, so 4 times 60 is 240. 5 times 2 would be 10, so 5 times 20 is 100, and 5 times 4 is 20. Okay, I need to add those together, so 1,200, 240, 120, and altogether that gives me 1,560. So now we know 24 times 65 is 1,560. But I didn't want to work that out. I wanted 0.24. Where does 0.24 come from? From 24. What am I dividing by? Dividing by 100. And I didn't want 65, I wanted 6.5. Well, how do I get 6.5 from 65? I divide by 10. So I'm dividing by 100 and dividing by 10. Altogether, I'm dividing by 1,000. Dividing by 100 and then by another 10 is the same as dividing by 1,000. So 1,560 would be 1.56. You could put 1.560, but we don't need that last zero, and that's just a placeholder. Okay, I know that it's 1.56 because dividing by 1,000 means I move 3 places to the right. So from 1,000 to 100 to 110 to 1, 1. Okay, adding and subtracting directed numbers. So we had this idea of whether things are being made more or less positive or negative. So we're going to look at things in the same way. So our first number is always where we start. So I'm starting at -2. And I'm adding something. So I'm getting more of something. If I'm adding 5. So that's like saying I'm adding +5. So my number is getting more positive. If I'm getting more positive, I'm going up the number line. So we started at -2. I'm going 5 up the number line. I need to figure out where that would take me. Well, to get to 0, I'd need to add 2. So to get 5 up, I'd need to add another 3. So I'd get to +3. So -2 plus 5 is +3. The next question, -2 subtract 5. So again, I'm starting at -2. That's just telling me my start point. I'm not doing anything else with this sign. I'm subtracting now, so I'm getting less of something. I'm taking something away. I'm taking away +5. So my number is getting less positive. If I'm getting less positive, I'm going to go down the number line. So I'm starting at -2. I'm going 5 down the number line. I'll get to -7. Okay, and if you're not sure, you can count that with your fingers, but we should know 2 plus 5 is 7. So if I go from negative 2, I'm going 5 more negative, I get to negative 7. And the last one, I've got negative 2 subtract negative 5. So this negative 2 is my starting point. So I'm starting at negative 2. I'm subtracting, so I'm getting less of something. But now I'm subtracting negative 5, so my number is getting less negative. If I'm getting less negative, I want to go up the number line. Going down the number line is getting more negative, so going up would be less negative. So I'm starting at negative 2, I want to go 5 up the number line. And we already did that above, I'd end up at positive 3. Okay, percentages of amounts. We should have some percentages that we do just remember how to work out. So to find 1%, we should know we divide by 100. To find 10%, we divide by 10. To find 25%, I divide by 4. And to find 50%, I divide by 2. And I'll find any other percentages using those. Okay, either multiplying them, adding them together, dividing them by things, but these are the ones that I will find first. So, finding 10% of 30, well, that's nice and straightforward because that is one of the percentages we've learned. I divide by 10. So to find 10% of 30, I do 30 divided by 10, which is 3. Nice, simple, done. To find 35% of 30, I'm actually going to show you 2 different ways. Okay, I could look at these amounts and say, well, hang on a minute, 35% is 25 plus 10. So I can find 25% of 30 and 10% of 30 and add them together to get 35%. So 25% is 30 divided by 4, which is 7.5. And 10% I divide by 10, so it's 30 divided by 10. We've already worked that out, that's 3. So if 25% is 7.5 and 10% is 3, adding them together gives me 35%, which would be 10.5. Okay, another way that you could have done that was to use this 10% being 3 to say, well, if 10% is 3, 5% is half of that, is 1.5, 30% is 3 times 10%. So 3 times 3 is 9, so 35% is 30% plus 5%, or 9 plus 1.5 is 10.5. There's usually a few different ways of doing those questions, and whichever one appears easier to you, that's the way that you should do it. Sometimes there'll definitely be some ways that are easier than others. Okay, but the key is to make sure we're using these percentages and then looking for dividing or multiplying them to scale up or down and find the other amounts. Okay, finding here, this should say find the highest HCF or highest common factor of 24 and 15. So a factor is a number that goes into one another. To be common, it needs to be a factor of both numbers. And I want the highest number that is a factor of both numbers. So my starting point here is, let's write out the factors of each of these. So the factors of 24, I could have 1 and 24 because 1 times 24 is 24. 2 and 12, 2 times 12 is 24. My next number to try would be 3. 3 times 8 is 24. My next number to try, I've tried 1, 2, 3. I try 4. 4 times 6, is 24. So 4 and 6 are factors of 24. And my next number to try would be 5. 5 times, no, isn't a factor of 24, because 5 times 4 is 20, 5 times 5 is 25. So 5's not a factor. My next number after that would be 6, but I've already got that included here. So I've got all the factors of 24 written down there. The factors of 15, I've got 1 times 15 is 15. 2 isn't a factor of 15 because 15's odd. 3 times 5 is 15. and 4. 4 isn't a factor of 15 either. So my next number would be 5. I've already written that. Those are all my factors of 15. What are my common factors? 1's a common factor. 3 is a common factor. 5 isn't. 15 isn't. And then I checked them looking through 15 as a list because it's got fewer things to check through than 24. So my common factors are 1 and 3. So my highest common factor, or HCF, of 24 and 15 is 3. Okay, skill number 5 were expanding brackets. This was something we were quite good at when we did it in class, so hopefully we've remembered how to tackle these questions. We've got 2 lots of x plus 5, so 2x5. Okay, I'm just drawing that grid. When we're expanding brackets, we're basically multiplying 2 things. It's very much like we did here, right, where we wanted to do 65 times 24. Here I want to do 2 times x plus 5. So 65 times 20 plus 4, right, 2 times x plus 5. Okay, and the size of that grid depends on how many things I'm multiplying by one another. 2 times x is 2x, 2 times 5 is 10, so that would expand to 2x plus 10. Okay, this is a little bit different, so I've got 3x now that I want to multiply by, let's have a look, multiply by x, subtract 5y, plus 2. So the difference is I had 3 terms inside my bracket. That's why I've now got 3 boxes here, because I'm multiplying this one term, 3x, by these 3 terms inside the bracket. 3x times x is 3x squared. 3x times negative 5y, so 3 times 5 is 15. So positive times a negative, so we've got a negative answer. And x times y, it's right as xy. Remember, if I'm multiplying letters with numbers or letters with each other, we don't need a symbol. And 3x times 2, 3 times 2 is 6. So 3 times 2x, so 3x times 2 is 6x. So we've got 3x squared minus 15xy plus 6x. I can't simplify that. None of those are like terms because this is 3 lots of x squared. That's lots of xy and lots of x for lots of different things. Okay, our final skill for this week, comparing fractions. So I want to see which is bigger out of 2/3 and 5/7. The easiest way to do this is to make the denominators of them the same. So we've got 2/3 and 5/7. Okay, so I've got, if I split a whole into 3 parts, so if I imagine having a whole, splitting it into 3 parts, that would be 2 of them. Here, I'd be splitting my whole into 7 parts, and I'd have 5 of them. It's not immediately clear which of those would be bigger. So what I'm going to try and do is split them into equal groups. So I'm looking for a common multiple of 3 and 7. Well, the easiest way to do this if we can't spot a smaller one is to multiply them together. 3 times 7 is 21. So I can write both of these as fractions over 21. So I can do 3 times 7 is 21. And to keep this as an equivalent fraction, if I've multiplied my denominator by 7, I need to do the same to the numerator. So 2 times 7 is 14. So 2/3 has the same value as 14 over 21. To get from 7 on my denominator to 21, I've multiplied by 3. So to make this an equivalent fraction, to make these have the same value, I need to multiply 5 by 3. 5 times 3 is 15. So 5/7 has the same value as 15 over 21. Which is bigger, 14 over 21 or 15 over 21? 15 over 21 is bigger, so the bigger fraction is 5/7. Okay, same as always. Try the questions, check your answers for the first day against this, maybe look over them again if you're struggling, look at the Hegarty Maths clips if you need to. Try the questions on across the rest of the week. Send your answers to me if you want me to check them. I'll upload them otherwise at the end of the week on Friday. And good luck.